Okay, so imagine you're a developer, right? You're staring at your terminal.
Hmm.
You navigate to this slightly strange folder, .rwkv-assistant,
Yeah, memorable name.
and you type python test.audio.py. Seems simple, but what are you actually doing there? What does that kick off?
Well, that command, it's basically your entry point.
Yeah.
It's the start of building something pretty advanced, like a voice-driven AI assistant.
Okay.
And the core of it, the engine, is this thing called RWKV. That's RWKV.
Oh, Aku.
Yeah, or receptance weighted key value, if you want the
Okay.
full name. This whole deep dive is really about unpacking RWKV.
Right. And it's described as this, like, fusion model.
Exactly. It's a really interesting mix. Think recurrent neural networks, RNNs, great for sequences.
Yeah, step-by-step processing.
Right. And then transformers. Big, powerful models like GPT, RWKV tried to combine them.
How so? What's the goal there?
The goal is pretty ambitious. Train it fast, like a transformer, using all that parallel processing goodness.
Okay, makes sense for development.
But then for inference, when it's actually running and talking to you, it performs with the efficiency of an RNN.
Ah, okay, so that's the best of both worlds claim I've seen. Fast training, efficient running.
Pretty much. The key benefit during inference is its linear time complexity.
Okay, break that down. OL.
Right, OL. So the computation time grows, directly in line with the length of the conversation LO.
Unlike transformers, which are OL squared.
Exactly. Transformers get quadratically slower and need way more memory as the conversation gets longer. It can become a real bottleneck.
Right, the dreaded KV cache explosion.
Precisely. RWKV doesn't have that constantly growing KV cache.
Yeah.
Because it works differently. It's recurrent.
So constant memory usage.
Constant memory usage during inference, yeah. And that also leads to this idea of a theoretically infinite context window.
Infinite context. Okay, that sounds like a huge deal for a voice assistant. No more forgetting the start of the chat.
It's a game changer for long interactions. Absolutely. Yeah. And another really key point, it's 100% attention free.
No attention mechanism at all. That's like the defining feature of transformers.
Yep. RWKV achieves its sequence processing without relying on those attention layers.
So how does that affect using it for audio, especially streaming audio where you need to process sound as it comes in?
Well, that's actually one of its strengths. Its recurrent nature is almost tailor-made for streaming ASR automatic speech recognition.
Because it just processes the next bit of audio.
Exactly. It takes the current state and the next input chunk, updates its state, and moves on. No need to look back over everything with attention. Perfect for unbounded sequential data like audio streams.
But wait, RWKV started as a text model, right? How do you get a text LLM to suddenly understand, raw audio waveforms?
Good question. That's where some cleverness comes in with projects like RWKV ASR.
Okay.
They don't retrain the whole massive text LLM. Instead, they keep it frozen.
Frozen. So its weights don't change.
Right. They add a small adapter module, and this is the crucial part, they use something called state tuning.
State tune.
Yeah, they essentially tune the initial hidden state of the RNN part of RWKV to make the existing text model understand speech input.
Huh. So you're kind of nudging the pre-trained brain to understand a new type of input.
Exactly. You leverage all its existing language knowledge without the massive cost of full retraining. Super efficient.
Okay, that's clever. And that leads to this RWKV transducer thing. The sources mentioned zero latency. That sounds ambitious.
It is ambitious and pretty remarkable. They've shown results with essentially zero algorithmic latency.
What does that mean in practice compared to other models?
Well, think about standard streaming ASR models, like shunt conformers. They might need, say, 320 milliseconds of audio future context to figure out the words. Latency.
Right, a noticeable delay.
The RWKV transducer, in contrast, needs basically just one frame of context, so 0 milliseconds of that algorithmic delay. And it does this with a tiny memory footprint.
Wow. So for you building an assistant, especially maybe for accessibility,
it means incredibly fast, truly real-time transcription. The words appear almost instantly as they're spoken. Fluid. Immediate interaction.
Okay, that covers getting speech in. What about getting speech out? The text-to-speech, the TTS part.
Right, giving the assistant its voice. RWKV fits in there, too.
How does that work? Is it a similar idea?
Sort of. Modern TTS often involves first turning audio into discrete tokens, maybe using something like a VQ-VAE.
Okay, like quantizing the audio.
Yeah. And then you use a language model to predict the sequence of those audio tokens based on the input text.
And RWKV acts as that language model.
Exactly. The RWKV TTS project uses an RWKV model for that LLM component, predicting the audio tokens.
And the quality, is it robotic or?
Surprisingly good, actually. The results are really competitive. Meet opinion scores, the MOS scores people use.
Right, the perceptual quality rating.
Yeah, those scores put RWKV TTS very close to actual human recordings and, other top-tier Transformer TTS models, often nearly indistinguishable.
Nearly indistinguishable.
Okay. Are there still rough edges, like maybe conveying complex emotions or specific accents?
Oh, for sure. There's always room for improvement in nuance, emotion, prosody. That's ongoing research. But for general conversational stuff, it's really natural sounding. Very convincing.
So let's circle back to that first command, python test.audio.py.
Yeah.
It's not just one thing running then.
No, definitely not. It's almost certainly an integration test.
Integrating what?
The whole pipeline. You've got the ASR module listening to the microphone.
Okay.
Feeding the transcribed text to the core RWKV language model for thinking or generating a response.
Right.
And then passing that text response to the TTF module to speak it out loud.
Got it. So the RWKV ecosystem is quite modular. You, the developer, have to kind of wire these pieces together.
That's a good way to put it. You're acting as a system integrator, but there are tools emerging to help, like RWKV Runner.
RWKV Runner.
Yeah, it helps you host the core RWKV model and gives it an API, often one that's compatible with OpenAI's API. Makes plugging in the ASR and TTS parts a bit easier. Okay, so let's recap the big plus points for RWKV here.
Sure. Number one, definitely that streaming ASR performance.
Yeah.
Very fast, very low latency.
Mm-hmm. And efficiency.
Huge efficiency gains, yeah. Linear scaling, constant memory, lets you run surprisingly large models, even on, consumer-grade hardware.
Which is great for privacy and local processing.
Absolutely. And third, don't forget the community. It's open source, and there's a really active group pushing it forward.
Right. So if you're listening and want to jump in, what's the practical advice?
Okay, so for ASR, I'd say start with the pre-trained RWKV ASR models. There are scripts like RWKV Speech Chat that give you a good starting point. Don't reinvent the wheel initially.
Makes sense. And for the voice, the TTS.
TTS is maybe a bit trickier to train from scratch. So definitely look at using pre-trained RWKV TTS models first, or, maybe even use an external TTS API while you focus on the core logic.
Okay, and integrating it all.
Check out RWKV Runner for hosting the main LLM. Then connect your ASR and TTS modules, probably via its API.
Got it. Any other tips?
Yeah, definitely join the RWKV Discord community. Seriously, it's incredibly helpful for asking questions, getting help, seeing the latest developments. It's a vital resource.
Solid advice. Okay, final thought then. Imagine you actually build this. A truly private, totally on-device AI assistant. It's hyper-responsive because of that low latency, understands you, talks back in real time, no cloud connection needed.
Mm-hmm.
What kinds of conversations could you really have that? What does that unlock when the AI is truly just yours, right there with you?